Schultz here. We're going to take a look at this lesson here, 11.1.2. I realized I didn't really go into this a ton in our last lesson, so I'm going to hit this a little bit more. So we've got CPM as a tool that we can use for this section. We also have got our TI calculator, and we've also got Desmos. Now, you guys know me. I'm a huge fan of Desmos. I love it. I think we should use it on everything. This is a case where actually TI does have some carry here. So you will probably see me more commonly use the TI, but just because Desmos feels like there's a little bit of finagling or kind of like making it work type thing. The CPM stuff is okay too. I find that sometimes students like this is because it's pretty easy to do stuff by hand, but I just tend to be a digital person. So I like to use one of the digital tools. So last lesson you saw me do some TI stuff. This stuff I'll have some Desmo stuff and I'll have some TI stuff, and we'll go from there. So if you want to get into the weeds on that, I wrote over this here, so I shouldn't. But if you just search for this blog, this is a really good blog that shows a lot of the information that I got for how to do stuff in Desmos here. So I'll pull that up here. But this is the blog here. So this is where I got a lot of my information as far as random number generators, as far as doing normal distribution with random number generators, things like that. We'll do more of this towards the end of it here, towards the end of the section. Yeah, so just this great blog that if you want to get in to the weeds on that stuff is interesting to you, please go after it because I think it's fun too. Let's jump forward here into our lesson. Specifically, we're going to look at casino games here. So I'm going to skip this first part, just try to make the video shorter. Basically, we're going to look at the game of roulette. And what happens is there's a ball that's dropped into a spinning wheel here. And the wheel has 38 slots. 2 of them are green. They are 0, 0, and 0. And the rest of them are either black or red. So what that means is that there's 18 black, there are 18 red. And then there's the 2 green. So what that tells you is that they're almost 50%. These are almost a 50% close to hit black or red, which is kind of that enticing thing there. And so we're going to kind of use that. And lots of times in this lesson, we're just going to ignore this green thing just so we can use that direct on 50% in our simulations to see. And then we'll go from there. So let's see what this first question looks like. Now, this first question is just basically a thinking one. There's not really anything to like write down here, just to think. When you're talking about a roulette wheel, players who watch play and then make a bet are called lurkers. So a commonly held belief among lurkers that once they see a ball land on red 3 times in a row, they should join the game and bet on black. Or vice versa. If they saw three in a row black, they should bet on red. What do you think? Do you think that this makes sense to 3 in a row? You should jump in because it's a 50-50, right? So we should go from there. So just kind of thinking about that, my quick fire thought there is that in theory, the mathematical thing there would say that actually it doesn't matter because each individual throw is that same 1/2. So if you threw 100 straight on red, your next throw, what is your probability? It is still just half. You still would have that half. Again, ignoring the green part, you'd still have a 50% chance to land on red, even if it's quote unquote due or something like that. But we're going to take a look at some of this and start to look at a curious thing about how when you get these long amounts of throws, when you get 200 throws, 300 throws, you can actually start to see patterns even in random numbers that are a little bit predictable, which is what's kind of interesting. So we're going to look at 2 of these roulette wheels. So wheel 1 and wheel 2, and basically it's talked about that there are rumors that some of the games were rigged. So this owner wants to find out, are they rigged? Are some of these wheels rigged? And so what we're going to do is we're going to run a simulation of 200 spins, and we're going to compare them against this piece here. So to run the 200 sims of this, I'm going to show you in TI, and then we're going to end up in Desmos here on this one. So I'm going to go into math, just like we did on last lesson, jump into probability and do a random integer. And I'm going to choose between 0 and 1 so that one of them is red and one of them is black. I'll do 200 of them. And you can just run this and see it as a list. I like to store it and then see it as like a list on the screen here. I like to store it into an actual list. So I just press that store button, and then I go second and then list. And I'm going to store it into L1. And I'm going to store all that stuff. So I could just on the screen here just click through all these numbers, but I get kind of lost as to how many times have I touched it. Did I do that thing? So I want to see it in the list. So I'm going to go to Stat and go to Edit. And here's my list now. And what's cool about this is that as I'm clicking down, you're probably seeing this number here change. Hey, I'm on the 9th number. Hey, I'm on the 10th. Hey, I'm on the 11th. And I can start to look here. And what I'm looking for in this list, I'm looking for these streaks. Because that's where we're going to go next when we get to the further guidance. But just to kind of call this out because it's here. 1, 2, 3, 4, 5, 6 in a row. That would have been one of the colors. That's kind of interesting because it's like, hey, 6 in a row feels like really low chance of that happening. And that's some of what we're going to be looking at is just when do these streaks happen, and basically how often do we think they should be there, and things like that. So this is it in the TI. Let's take a look at Desmos here. So this is the formula that you type in. This part out front here, that's telling you the numbers that you're going to randomize. So if you're trying to do a dice, you would change these numbers to be 1, 2, 3, 4, 5, 6. So you'd have the numbers 1 through 6, and then dot, and then random. And then inside here, this is the number of times that you want it to generate. So if I was going to do this again here, there's actually 2 ways that I could do this. I could retype the formula here and then say, hey, this time I only want to generate 100 numbers, or this time I only want to generate 40 numbers, or something like that. You can also just do this as well. Just hit the shuffle button here, and it'll start to give you new numbers there. I kind of like the Desmos look on this because I can just see a lot. And again, my goal here that we'll see eventually is that I'm looking for streaks. And notice, hey, look here, there's another one of these streaks that is happening, and here's another one right down here. So we'll look at that in just a second. But let's jump back to our problem here and go from there. So I'm actually going to jump back to this slide, and I'll show you that, again, we're looking for these streaks. So I've highlighted some of them. So the first wheel seems to have some of these streaks that are happening, and they all seem to be over 4. So like here, I've got a streak of 1, 2, 3, 4, 5, 6, 7, 8, 9 in a row. I've got a streak of 1, 2, 3, 4, 5, 6 in a row. But my second wheel, my biggest streak is 4. 4 seems to be the cap, and then it goes into my next number there. So let's get into this further guidance where there's actually some questions so we can get there. So we are first going to make a guess. Do we think that a wheel is rigged or not? And then go from there. I'll let you decide that. Then we set up our simulation. So we've done that. And then it asks, how many streaks of 5 or more reds or blacks in a row did you get? Compare with your classmates. So I took a screenshot of one of my random things in Desmos here, and I just looked for where my streaks are. And I just did this so it was bigger and easier to do instead of doing it live. So 1, 2, 3, 4, 5. Here, 5 in a row. That's 1 streak, 2 streak, 3 streak. That's more than 5. 1, 2, 3, 4. Here's another one that kind of wraps around 5, and then 6. Did I count that right? 1, 2, 3, 4, 5, 6. Yes. So I got 6 streaks that were 5 or more, and maybe I missed one. I don't think I did. But I got 6 streaks of 5 or more in a row when I did my random number generator there. So jumping back here, I got 6 streaks when I did it, which a sample of 200 feels pretty convincing to me that might be that. And even if we jump back to our list here, we had one kind of right away there. Here is another one right there. Here, that's 4, so that's not quite it, but we are seeing these streaks kind of pop up with some level of frequency that seems to be more. So we're going to jump back here. So which wheel might have been rigged? Originally, when you look at this, you go, that first wheel, it's got this streak right here that's got like 9 in a row. Yeah, right, this is a rigged wheel. But actually, when you dig into it and you go, oh, hey, wait, there's nothing over 4? That seems a little strange. So then maybe actually it is wheel 2. Wheel 2 is the wheel that is rigged because nothing's getting these long streaks like we're confirming with our simulation. So then the next thing is, would it be an advantage to leave it that way? I don't know. I feel like you could make an answer both ways, and be like, well, if you have those lurkers, the lurkers would have more of a tendency to kind of hit faster because you're never getting over that like 3 or you're never getting over that 4 number. Whereas the other one seems to be more random. So like you could kind of talk about it in both ways there, um, but uh, but like it just kind of depends on how people bet. So there's that. And then write up your report. Well, we just kind of talked about that. So that's our roulette wheel. Let's get to our next program here and our final one in the section. So now this one, as you can tell from this, I'm going to be into the TI stuff here. So it says this. Caitlin is going to babysit her nephew a lot this summer. She has a great idea that one way to entertain him is to walk to McBurger's for a kids' meal for lunch. The kids' meal comes packed randomly with one of 6 equally likely action figures. Caitlin's worried her nephew will be disappointed unless he gets all 6, so she wants to know how many meals she can expect to buy before he will get all 6 of them. So we're going to model this again. We're going to model it with the digits 1 through 6 and create a large number of samples, such as 200. And then we're going to start to just hand record how many times it takes to get to all 6 action figures. So we can do this. Again, it doesn't matter to me if you want to do it in TI or if you want to do it in Desmos. I'm kind of all ready here, and I kind of want to show you this when you go to more numbers here. 5 and 6 action figures, and there we go. So just in this case, Desmos seems to be a little bit cleaner on this. So I'm jumping in here, but if you wanted to see it on VTI, kind of a similar process here. I'm going to go over and I'm going to go down to random integer, and I'm going to choose the lower number to be 1 and the upper number to be 6 because that's the 6 different ones. 6 and then go through there. And what it's showing on the screen back here is it's showing you how to kind of like see this, So the first meal they got figure 5, then figure 6, then figure 4. So you just have to see how many times you go to do that. So we can do that and then go, okay, so we got 1, he's got 3, he's got 2, he's got 5. So he's missing 4 and 6. So here's 4, here's 6. And he would have gotten all of them by meal 1, 2, 3, 4, 5, 6, 7, 8. By meal 8 in this case. Let's take a look at what Desmos says. So here's 5, 1, 5, 6, 5, 3. There's 2, and then finally 4 down here is our last one that we'd be looking for. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them that you'd have to get there. So in this problem here, we are just looking at this, and depending on how random it was, I forget what the one number was, but on Desmos we had 11. I believe on the TI I want to say it was 8 if I remember right, but I don't remember for sure. And then it says run your simulation 10 more times. Well, you might have noticed that I could do that again pretty quickly here in Desmos. I could also do that decently quick here in TI, basically run it back again and just run it a few different times. And the goal is to figure out what is that time, how long is it going to take here. So let's do this in TI just because I'm here. So 2, 3, 1, 5, 4. We're just waiting on 6. So there's our 6th one. So that's 1, 2, 3, 4, 5, 6, 7, 8 again on TI. Then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I still don't have it there. 13, 14, 15, 16. There we are, finally 17 before we get that last action figure. So jumping back here, I had a few more times. I had a 17, I had an 8. Again, from our Desmos one, we had 11, we had 8. So we're seeing a number start to kind of come out here. And we just need to find a few more averages. Let's jump over to Desmos, just get something different here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11. So here's another 11 on Desmos. I think I've got all those. 1, 2, 3, 4, 5, 6. Yep, so here's 11 on Desmos. I'm just going to write that on the iPad Going to generate another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 this time on Desmos there. And I think I've got all the numbers. Yep. So here are our numbers. Jump back to the iPad. So there were our last two. So now we just got to find the average. So I'm going to add all these things up and divide by the number of numbers. So I've got 17 plus 8 plus 11 plus 8 plus 11 plus 10. And I'm just going to divide that number by 6. And I'm going to find out I'm at about 10.8. Let's call it 11 here. So I've got 10.83 or 11 times. And then you're supposed to compare with a bunch of other people and go from there. Now this is just one sample, so obviously there's a range because we had up to 17, we had down around 8, which is kind of crazy to think about. And we had 8 pop up twice. The actual mathematical thing here says that it should be about 14.7 meals that it takes. So we're actually a little bit lower. So if you're doing this with me and got your own, you might have a higher average than mine, which was that 11. Our last thing here, D, estimated range of meals you think you might need to buy. What is the most that you might need to buy? What is the least? Do you think it may be possible that you might have to buy 50 meals to get all of the action figures? Well, we just did, like 6 samples here, and we got some pretty different results. In theory, it's possible that you could have to buy 50 or 100 meals because it is possible to just get really unlucky. Is it probable? Probably not. So a range, it's not really, it's basically a feel thing here. So for a mathematical average that we found out was about 14.7, well then you might set your range as most likely maybe we're between 20 and about 10 meals. And I'm just kind of going halfway, saying about 5 this way, about 5 this way. We will get into how to do like some of that estimating there. And go from there, which I should actually write this as 10 to 20. But this is a feel thing. There is nothing that's like mathematical about that and kind of what's happening there. So, all right, that's our lesson. You've got your review and preview last, and I will see you next time.